Oh, microphone. All right, so here we go. 14, I think, is where we stop, so we'll start with number 15. That does not mean radians. That actually means a reference angle. So hopefully you remember how to start at 0, go all the way around the horn, 320 degrees. And what is the reference angle going to be? Yeah, it's 40 degrees. Remember, it is always to the x-axis. It's never to the y-axis. It's always to the x-axis. Oh, yeah, it's never negative. Okay? So all out for theta equals 6. What's the first thing you have to do? Yeah. Yeah, change it to, since our answer's in degrees, change it to degrees. So 6 over pi equals theta over 180. Multiply it over. 6 times 180 divided by pi equals theta. So what's theta equal? You have a calculator? There's expectations if you sit there. So what do you get for the 3? No, you don't. 6 times 180 divided by pi? 343.8? All right. So yeah, so you draw it out. Find the reference angle. So it's going to be, oh, you're 7 ahead of me? Yeah. 16.2. Okay? Because you take 360. So you're either going to use 360 or you're going to use 180. 16.2. Okay? That one wasn't too bad. Approximate 3 decimal places. What mode do you have to be in for this one? Radian. And how do you type in secant? See, that's an identity people remember. You don't need a note card. 1 over cosine of 0.26. Mary, what did you get for that? 1.035. Are you going to have one for Monday? Okay. All right, here we go. What does approximate mean? Means use the calculator, right? Remember I told you every man of the question is important. What's this mean? The nearest 0.1 degrees. Yeah, that tells you to be in degree mode. What's the 360 tell you? X max. What's 0 tell you? X min. And usually the X scale is either pi over 2 or 90, so in this case it'll be 90. Clear. Y equals, figure all that out. View. So cosecant is 1 divided by sine. What?
Didn't you predict that we would win stocking?
Yes.
She skyrocketed in the first place, the 21st.
Nice. Why does he still doubt me after all these years? Why does he doubt me? Let's see. Window mode degrees. And we're set up. There's 1 and 2. Which button do you use to find that? Yeah, intersect. Second, calculate, intersect. First curve. Oh, I need a number on that. Y equals is on the asymptote. There, I'm off now. First curve, second curve, guess. It's close enough. 137.7. Hits me right there at E. So that means the other one should be 42.3. I could calculate it to make sure. Second, calculate, intersect. First curve, second curve, guess. I'm going to guess 42.3. And look at that. It actually worked. Okay. All right. Questions? Yeah.
Could you just set it up like in a unit circle?
You could. You have to know there's two of them.
Yeah.
And you have to know the y coordinate is 1.485. Okay? That's another way of doing it. Degrees are easy. Radians are just a little bit more challenging. Same situation. So, this time we're in radian mode. This time y equals sine 0.0135. Window is not from 0 to 360, but 2 pi. Scale, pi divided by 2. Since I'm doing 0.0135, I think I'll go 0 to like 0.02. Yeah, just so I can actually see the intersections. I like to see them. Window, mode, sine of x. Oh, the other one's probably really small. Second, calculate, intersect, first curve, second curve, guess. 3.128. And so it's probably this one. I'll double check that with the 0.01. Second, calculate, intersect, first curve, second curve. My guess is going to be 0.01. 0.013. Oh, so I rounded. Yeah. And now you can also do a unit circle. Okay. Questions on that? All right. Riley, how do you find the amplitude? Yeah, it's a number in front of the sign. And how do you find the period? Kerrigan. 2 pi over b, and there's b, and then there's x minus c plus d. So what's b in this case? Let's see, that'd be a, and then b is what? 4. So 2 pi over 4, so it gives you pi over 2, and 1/5. Okay, but it follows that format we talked about, a sine b x minus c plus d. So that goes pretty good. All right. This one does not require a calculator, so how do you rewrite this one first? Jared?
Y equals last time before, and then parentheses x would be our rate.
It would be our rate plus 0. So the amplitude period is 2 pi over b, and this is the phase shift. Is it positive or negative phase shift when it's x minus c? It is positive, pi rate phase shift. Okay, so hey, it looks like, because on this test they don't distinguish the amplitude, always has to be positive. So yeah, so it looks like the answer is going to be pi over 2. Yeah, it looks like it's going to be A. Yes. Question? The amplitude is supposed to be positive, but I'm not going to go through it. Why all negatives? Okay. All right. Moving on. Find the graph. What's D in this case? Where's the middle of the graph at? 0. What's the amplitude? 3. B. How far is it from dots? If I make 5 dots, how far is it from here to here? Yeah, the period is pi. So to find b, you have to do pi equals 2 pi over b. So what bb? bb. Yeah. So that implies that b would equal 2. So that's pretty good. Now the question is, where do you want to start the dots? Well, if I start at 0, it would be a cosine curve, wouldn't it? And that's not a choice. If I start back here at sine, that's at negative pi over 4, right? Because it's halfway. Does anybody see one that works? This one looks like it works. 3 sine 2x plus pi over 4. Amplitude 3, period pi, phase shift, negative pi over 4. That looks good for sine, doesn't it? 5 dots, 1, 2, 3, 4, 5. I don't know, there might be other ones that work. That one looks like a winner. So far, so good? All right, how do you find the period of cosecant? Emily. Okay, cosecant has the same period, and looks like b is 1 in this case, so it'd just be 2 pi. It's kind of a dud question.
Which are the ones with pi would be? Is that just cotangent?
Yep, cotangent and tangent have period equals pi over b. Okay? Tangent, cotangent. All right. Oh, look at that. What timing? So it'll be pi over 4. C for tangent. C is the midpoint. Nope. Cotangent, it's at the... So you have tangent looking like this. And C is right here. Okay? And then over here, that's the amplitude A. All right? Find the period of this equation. So it's 2 pi over b. What's b in this case? 1/4. I still am surprised how people miss this fraction when they calculate it. 2 pi divided by 1/4 is a pi. Ooh, here we go. Find the equation using the cotangent function on the same graph as tangent. I'm going to do something on the calculator. I don't know if I've done it here before or not, but I'm going to put in tangent of x, and cotangent is cosine of x divided by sine of x. Don't use 1 over tangent. You'll get the wrong picture. And then I'm going to go with radians. Window, 0 to 2 pi, pi over 2, that's set up. And then what I'm going to do different is I'm going to slide back to where that cursor's flashing and change it so it becomes a thick line graph, so I can tell the difference between the two. So tangent will be skinny and cotangent will be thick. And then I got to change my window. Window. I got to change my y's. -5 to 5, something like that. There we go. So the skinny line's tangent, the thick line's cotangent. So I want you to be able to figure out how to modify the graph to get it. So what's one change to make? Yeah, so I said, or she said flip it. So we'll put a negative in front of here. Graph it again. Looking on the right direction now. Now what do you have to do? Yeah, move it one way or the other, right? How far? And that's where your scale is kind of important. That's why I always pick pi over 2. Yeah, that's pretty obvious in this case. It's going to be pi over 2. And so I have to change it in both here. You want to go left or right? I don't think it matters, does it? Second, insert minus. Huh?
April, the answers are all added.
Oh, I can add it if you want. I don't think it matters. Because it's the same way. Second insert divided by 2. Then this one is plus second pi divided by 2. And the graph, so thin and thick should be together. Once you overlay the other one. Now, I'm not sure if I've done. I do it in calculus, but I don't know if I've ever done it here with 2 different graphs. Okay. Questions? So I believe that answer corresponds with the letter. Which one? D. Okay. All right, this one looks pretty easy. Anytime you see radical 2, it's pretty easy. Do you remember what this symbol means? Means what? Capital C. A, B, capital C. So B is 9 root 2. C is 18. How can you find the other missing parts? There's 2 ways of doing it. One's on the calculator, and one is using a reference triangle. Cole, which way do you do it? Okay. 45, 45, 90. We said root 2, and 2. Yeah, so that means small a will be 9 root 2. This is 45 and 45. Yep. You saw the root 2 in there and it said exact value. But it says exact value, you only got 2 triangles to choose from. The other way of doing it on the calculator is to, if you're looking for B or A, it doesn't matter, but you take the sine of B equals 9 root 2 over 18. And when you punch in the inverse sine of 9 root 2 over 18, you get 45 degrees. As long as you're in degree mode. Okay? And that's how you can tell also it's 45, 45, 90. All right? So exact values are going to be 1 or 2 triangles, the 45, 45, 90, or the 30, 60, 90. Okay? Short leg 1, hypotenuse 2, this is root 3. So ours are good? Coming down the home stretch. That's 27. 28. How'd you do this one? If you did it already. Yep.
I did it with height of 17.
Okay.
Angle of 3.
Well, I always do it because depression's always down and elevation's always up. Off the horizontal. Okay, so you put the 62. Okay, so yeah, the elevation depression is always off the horizontal. It's called line of sight. And Independence Day they talk about line of sight. And that's kind of a big deal when you're trying to triangulate something. I don't know if anybody ever picked that up in the movie or not. Well, next time you watch it, you will. All right, you don't know how tall the object is, but you do know it makes a right angle with your line of sight. Okay. What's the question asking for?
How far away it is.
So would that be C or B for lack of better? Because you know A in this case is going to be 17. Yeah, so it'd be B. So what trig ratio are you going to use for this one? Right. Tangent of 62 degrees equals 17 over B. What mode? Degree mode? So B tangent of 62 equals 17. So B equals 17 divided by tangent of 62 degrees. So we get for your final answer.
2.0.
Okay. I've already done the airplane problem, but it's not been recorded yet, so I get to draw it again. Nice. There it is. Again, this is chapter 5, I think. Is it? So everything's a right triangle. 10 degrees. Where's the 12,000 feet go? There's the height. Height is always measured perpendicular with the base. They always make a right angle. So what are you going to find? Yeah, what would be the hypotenuse? What trig function would you use? Yeah. So sine of 10 degrees equals 12,000 over C. So what do you get? You do not. How much is it? C? 69,105. That's feet. So if your rate is 260 feet per second, how can you find out how long it would take? Huh? Yeah. Distance divided by rate equals time. So if you divide by 260 feet per second, how many seconds is that? Right, but don't mark E as your answer. 266 seconds is how many minutes? Around 4-ish. Okay. Somebody marked 266 minutes. I said, that's a long time for a plane to keep climbing. 266 minutes. I don't know if you've ever flown before, but I think they'd be out of the atmosphere by then. Even at a 10-degree angle. Okay. I mean, there's people doing it now. They're going to start charging people for it. 30. How'd you set this one up and solve it? I mean, there's no one approach better than the other approaches, but what would be a good approach? Yep.
I did 2 different equations, one is tangent of 31 degrees, 45 minutes, for 110, and tangent of 50 degrees, 5 minutes, for 110, and then I have, no, I subtracted something.
Okay. 31 degrees, 45 minutes. Both 110, right? So there's one height and there's another height. So the difference between the two, h minus a cursive h, is going to be your answer. And you said tangent, right? Okay. So tangent, 15 degrees, 15 minutes equals h over 110. And tangent of 31 degrees, 45 minutes equals h over 110. So you have 110 tangent 31 degrees, 45 minutes minus 110 tangent 15 degrees, 15 minutes. Yeah. It's only 5 minutes? Which one? Oh, okay. Thanks. It's 5 minutes. And you remember how to use the minutes on your calculator? You can either type it in using your second and angle, or you can divide it by 60. Okay? So what do you get? 38.4? That's a long way for a balloon to go up, 38.4 kilometers. That's really a long way.
But it didn't say how long it took.
That's like miles.
Yeah.
It would. You're like that guy off Red Bull that went off the thing. This was before that, so yeah, you're probably right. Oh, I need to say this for so Lucas has something to listen to.